Yes, hope all of us are doing great. My name is Ernest, and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome each and every one of us to my channel, and I'd kindly like to request our members to subscribe and engage us in the comment section, and also ring that notification bell so that you can be getting updates on various discussion we have in sciences and mathematics. So in this particular discussion, we're going to look at the relationship between volume and temperature, and of course that's volume and pressure. And that's going to give us one of the aspects of the gas laws that we mentioned in our previous discussions on the concept of pressure, temperature, and volume. Now, in this case, the specific aspect of what we refer to as pressure and temperature of a gas can be determined using a particular instrument. And this instrument is referred to as a manometer. So this particular instrument can be used to measure the pressure of a sample of a gas in a container. And of course, we're going to see that using this specific aspect of pressure, we can develop a relationship between pressure and volume using a manometer, of course, whereby some experiments have shown that the product of pressure and volume that is obtained at a constant temperature basically is equivalent to a constant. And of course, we're going to see that some samples of experimental data that we're going to use basically is going to produce this particular relationship. Now, in this particular case, I've mentioned the concept of a constant temperature. Now, this one implies that as we're going to vary the temperature, then therefore we're going to obtain various values of course, this specific relationship of pressure and volume in that specific order. So therefore, I'm going to give a sample of a particular data that has been obtained. And this is an hypothetical value, of course, which is an experimental data, which is going to assist us, of course, understand this relationship between the two. Now, from this specific sample chart that I've given at the bottom of my table, this constitutes of the column for volume in terms of milliliters, and then we have pressure in terms of millimeters of mercury. And the last column is the product of this specific volume and pressures we're going to see. Now from the first row, then therefore we are having 5 milliliters of the volume of pressure, or rather 5 milliliters of the volume. And then we have a pressure of 76 millimeters of mercury. And the product of the two is going to give us 3.8 times 10 raised to power 2. And then if we vary the volume by increasing it to 10 milliliters, we're going to obtain the pressure of 38.1, and therefore the product given as such. And that specific order, we're going to see that if we increase the volume by a factor of 5, or rather by the difference of 5 millimeters, then therefore we're going to achieve an increase in pressure, which of course is significantly going to be proportional to that. Now the product of the two is going to give us this specific constant, which we have basically defined from this specific relationship that I've given above. So therefore, we can give a relationship between the pressure and the volume in terms of graphical representation, which is going to give us the relationship between volume of a sample of a gas and its pressure at constant temperature. And of course, the various studies that were done by some scientists showed that basically this relationship is true. And the earlier scientists who had done these specific experiments include Hooke, Power, and Townley. But of course, this was more explained and published by Robert Boyle. So therefore, it's going to culminate into the concept of the Boyle's law, which we mentioned as one of the basic gas laws that we are going to come across. So therefore, this is going to represent pressure and volume. And of course, we're going to have a graphical representation given in that specific order. So therefore, we're going to have this particular y proportional to x, whereby we're going to have y equivalent to k times 1 over x given as such. So this basically represents the concept that if we have pressure times volume, then therefore we are going to have a constant given as k as such. So therefore we can represent this particular aspect of pressure using k times 1 over v given as such. And this is basically the relationship that we are describing from the graphical representation that I've given on the board. And this basically is going to be giving us the concept of Boyle's law, which gives the relationship between pressure and of course volume of a gas at constant temperature given as such. So these ones, among other laws, are going to assist us come up with the whole aspect of the gas laws. And in generally, we're going to obtain the concept of a combination of these are going to assist us obtain the general representation of a combined gas law, which of course are going to be very essential for us in understanding the various properties of gases that we're going to come across. So in this case, I hope that we have understood the relationship between pressure and volume of a gas using this particular experimental data for the relationship between volume and pressure as given on the board. So that is it for now, guys. Kindly check our description boxes for various links of other videos which are similar to this, and they are going to assist us, of course, understand these various aspects and the concepts in a better way. So that is it for now, guys. Bye. God bless you. Don't forget to subscribe.